All right, good afternoon, folks. So today we're going to talk about how Gap was able to scale 100 times more with Redis Enterprise. All right, so I'll take a brief moment to go over the agenda. So we'll start with some introductions. I'll go over the international footprint for Gap, just to understand the magnitude of operations at Gap, a big retailer like Gap. Then I'll go over our journey. What were the challenges? What was the business requirement? What did we learn along the way? And all that good stuff. All right, so without further ado, hello again. I'm Junaid Fakhruddin. I'm a director of IT at Gap. I basically focus on the product architecture and engineering aspects at Gap. And the product lines that I deal with is distributed order management system. And my colleague.
So I'm Bill Hannan, and I'm a software developer at Gap. And I've been with Gap for 4 years, and I'm happy to share what we did.
Excellent. All right, can everybody hear me all right in the back? Good. I see nodding heads there. That's awesome. So Gap, as most of you guys know, is an international brand, and it has like a lot of brands that are part of the same umbrella. So just briefly, we have over 3,000 stores on an international scale and a footprint. Oh, that didn't change. How about now? Okay, good. All right, so, and I'm going to focus more towards the fulfillment operations at Gap because that's where the problem statement lies. So we offer many various programs for fulfillment. I listed out 3, but it's not limited to all 3 of them right here. So you can buy something online and ship it or pick it up from a store. You can ship an item from a store to do like some cost savings because the store is near to you. That's all internal behind the scenes for us. And then you can order in store. So something that you have, a store that you like that's close to you, you can just pick that store and then order all your products from there. So we kind of logistically move products to that store and then ship it from there or make it available for you from there. So I'm not going to drain the slide with the numbers. There's a lot over here. But in short, we have over, like, this transaction counts in millions. We have 3.2 million customers worldwide. And if you look at the permutations around, like, who's going to shop at a particular period of time, given that we are a 24/7 operation, it becomes pretty complex really quickly. So just to imagine this scenario where you need to make sure that the inventory is visible to all of our customers in real time, you have to ensure that all the logistics, all the attributes of an inventory are up to date at all times. Now, we had all of our processes running beforehand, like using batch processes and things like that. We had other ideas, how do we modernize this and how do we streamline this using the data streaming models, but we'll go over that in a bit. But in short, it's a pretty huge operation, tons of permutations of inventory visibility, and we'll focus on that because that will land us into the problem statement. All right. So what did we strive to achieve? And what were the business requirements for us? So have any of you guys shopped at Gap or any other? Can I see a show of hands? Excellent. That's really humbling. Thank you, guys. OK. So our approach was, or the business requirement was, to provide the most accurate timelines for fulfilling a customer order. And I would like you guys to take a moment to visualize this, that as you're clicking through adding certain items to your cart, at that point in time, we're constantly calculating in real time and giving you the opportunity to see when that item will be shippable to you in real time. And that's all driven by your persona. So our customers with different personas, they come in, look up our website, and then start adding items. And while they're adding items, you get like all the options for you to basically get the product delivered to you in a particular timeline that is acceptable to you. All right, so there's a lot to unpack here, and I won't do all of that, so I'll ask my colleague Bill to come over the stage and just do the rest of the nuances that are available. Thank you.
So again, I'm Bill Hannan, and I'm a developer at Gap, and we mostly worked with all the inventory systems and sourcing optimizations. And to understand why this problem statement is actually a big challenge in itself, I would have to give you an idea of what we have today and what we needed to make changes in that to go to the next level. So at a very high level, Gap has built in several optimization algorithms that for any given online order, it will go and fetch the most optimum node, or nodes, depending on the order. So to do these, to run these algorithms, there are several factors goes in, like how close the node is, how big the node is, what the node has, what capabilities it have, all these kind of attributes. And these are only some of the attributes that are tied to a node. Now, to run these algorithms, there are several attributes which are not just for node related, several other factors that goes in. So a user comes in, gives a checks out their order, and these algorithms kicks in. So now if you see there's a disconnect between the user and these algorithms itself. There's a small time gap. The time gap is not big. It's not in the order of hours or so. It's in mere seconds, but seconds is too much for computers. And in real world, within moments, things change. And because these optimization algorithms take so many factors in them, a minor change in any of these numbers can make a big difference in deciding which node it is. So the bridging of this time gap, that means running these algorithms, at the same time the user is looking at the website, was very lucrative for us. But it also means that it comes with its own challenges. Now, these challenges are like performance. These algorithms, we built it so that it could be run in an asynchronous mode. But now that we want to run it in a synchronous mode, we cannot wait for these algorithms to work on their own pace. A user is waiting on the end of the UI for a response. We need a quick turnaround. The SLAs must be aggressive for these APIs that we were going to build. So when we started looking at where we can speed up things, try to look at all the bottlenecks, that was a challenge in itself because these applications were built for close to a decade or so. So that means these are all big monoliths talking to another big monoliths, and they are talking in really non-standard integration patterns. So with all these challenges, we have to figure out what can we do and where we can do. And now these systems that we work on, these inventory systems, lie in the middle of critical path of all the product flow. So our upstream and downstream systems, their data integrity, everything relies on my system to be properly doing what they're supposed to do. So we did look at all these characteristics that we need on the new API, whether we rebuild it from scratch or we make changes to the existing ones. It has to be seamless, smooth, transition cutover, and we had a very aggressive delivery timeline. So we came up with several execution plans. We looked at them, see all the trade-offs, and we decided we will go with something like this. So we said we will split all the reads and writes. All the writes goes to our existing database, goes and writes it, and every change that happens, create, update, delete, anything, we will stream it to a new database. So now this new database, we created it such that these are all read optimized. Every change that goes in, we will make it so that it's quick to search, to fetch a single document, or to fetch multiple. Whatever the case may be, the access pattern, based on that, we made it read optimized. And this new database, we built it on Redis Enterprise. And the re-optimize the fast search part, I rely for that on the Redis search module. So I create all these secondary indexes using that module. I fetch, search, aggregate, do all of these using that module. It makes my client app really simple and easy because it's all transparent for it. It doesn't know what's going on behind the scenes. It doesn't need to do all those things on my client API. So we did implement this, and we did put a flag on it saying that it will let me control what I'm streaming to this new database and when I'm streaming it. And because, as I said before, this is a critical path system, we needed to run very rigorous and repetitive tests on it. So I would turn on the flag, let the data stream, collect their metrics, analyze it, and then repeat it again. So from all the times we did turn on the flag and collect metrics, we did see collect some metrics, and that's something like this. So if you see all the operations, all the relevant operations, meaning the writes, the reads, the search, aggregations. Sometimes, depending on the use case, it happens, combination of these. So we saw that there were around 25,000 operations per second. And you see the jump because that's when I turn on the flag, collected some metrics, and turn it off. So most of them, most of the times when I do this analysis, we would see that on average, all these operations will be under 3 milliseconds. Now, out of these operations, if I split all the records that were write operations, this is where I was streaming. This was also crucial for us because of these two database, we don't want them to be out of sync for too long, because all our writes, all our reads were happening on this new database, and because we were intending it to run all these algorithms real time, we wanted it to be as close synced to the writes. So the down graph that you see is we were writing about 10,000 writes per second, and all of them were under 1 millisecond on average. Now, these were the latencies on the database side. Now, once we moved all the reads from Redis, our application itself saw an improvement, about 100 times improvement, just for the searching of all the inventories and stuff. And the write part, we saw around 40 times improvement of our legacy apps. And with all these, we are still in the process of migrating all the data, and we're still doing all this repetitive regression testing. And till now, we are seeing good numbers. And I will ask Junaid to come back here and take it over.
All right, thank you so much, Bill. This is awesome. All right, guys. So we are 100 times better now. That's thanks to Redis. And apart from the approach that we took, the architectural approach for event sourcing and the data to a read optimizer, a fast layer, we can see that we're using we're doing a mind shift over towards how we used to approach the problem, or how we used to optimize our movement of inventory and sourcing. So with that, what we're trying to do, we flip the data model a little bit, tweaked it in a way that it's compatible with Redis Search. So we're using Redis Search in our ecosystem. And even with that module added as part of another abstraction layer over all the nodes that we have for Redis, we're still seeing a lot of performance gains, which we didn't see in a regular relational database earlier on. All right, so the good question here is why Redis Labs? Maybe too far out. But as we went through this journey of selecting a technology that's suitable for our architectural design, we looked into a few parameters. We wanted a fast layer to serve this data. And we wanted to be able to search over like millions of records really quickly, millions or billions of records pretty quickly. And we looked at like the open source offerings, like what we can maintain and manage, and we looked at for our enterprise offering for Redis. Redis Labs checked all the boxes for us. The most important ones we have listed here for high availability, the architecture, it comes out of the box for you. So you can do all of that with open source Redis too, but it takes a lot of plumbing work. It is a very pluggable ecosystem. We have different modules loaded into Redis seamlessly. Redis Search is one of the components that we use heavily, where we have actually flipped our data model and used those indexes to search quickly over the results, and we get those performance gains. Apart from that, some of the other elements that are really crucial for an enterprise in terms of the operations is the business support. So that comes also out of the box. You get the flexibility of maintaining multiple databases pretty seamlessly. You have the automated failover support. And you also get the operational insights all baked into the package. So some of the things that are really crucial to us, especially the operational insights, so that you're not flying blind into going and adopting a technology or tooling for yourself. All right, so what did we learn along the way? So we can distribute that over 4 major domains. So first off, communication. Communication is really important for an enterprise as big as Gap. We have many stakeholders that are part of a business vision. For instance, here we were looking at a personalized fulfillment offering. But in order to get a buy-in, specifically just for that one technology, wasn't enough. We had to share our vision and tell our customers or business stakeholders that how are we going to plan to phase out that approach. So it's really important for us, or was our learning for, get and every one of our product architecture, product management, and the engineering teams on board early enough so that you can continue down this path. One more important thing after this is that since it's a critical path system, all of your inventory data is being moved within that ecosystem. Right now, your online, your revenue, accounting, everything depends on this as part of the critical path. We have to do this very safely and do it in a way that's very durable. So at Gap, we have this product architecture group, which is combined experience of, I don't know, like maybe 100 years into this technology vertical. And they're very focused on providing or assessing like very durable solutions that is crucial for our enterprise. So we needed to get a buy-in from that. So that goes through certain reviews. We make sure that the technology is vetted out, the architecture, the whole pattern is vetted out. So all of that was part of the plan. The next important goal was to train our engineering. So everybody learns like at their own pace, and everybody has a different way of approaching certain things, especially engineers. We're very creative folk. So we want to make sure that we invested heavily into training. And we partnered with Redis Labs to do a lot of workshops and roadshows across our enterprise to get everybody onboarded to our ecosystem. So that was really crucial for us because now we have a team of engineers who know how to easily work with the technology and the tooling. We have the architectural pattern in place that can be replicated in other modules or other domains of the organization. And lastly, but most importantly, being brutally honest with your vendors in sharing your feedback. What that gives you is that as both of these companies, the vendor and the client, we're going through an innovative journey, there will be new challenges. And as long as we keep each other honest and keep each other on their toes, we're able to succeed together. So that was one of the most beneficial things that we saw out of Redis Labs as our partners. All right, and lastly, it's not over yet. So we're taking baby steps towards getting to our end goal. This is first cut of the problem statement that we went through, and this is our journey. We are a 24/7 operation, and our requirement to produce the most up-to-date inventory and the most accurate, in its most accurate and the most timeliness form is crucial for us, regardless of whichever product basically deals with our platform. What's next on our horizon for us is disaster recovery, failover configuration that we are working on right now. And it seems like pretty straightforward, but our ecosystem is spread across like a hybrid cloud model. So we have to make sure that everything's ticked and tied and we have the right approach towards BCP and disaster recovery. Now, what's desirable from Redis? Since we're using Redis Search, we're actually experimenting with an active-active configuration. And what we're trying to figure out is that what would be the most appropriate approach for having two multi-master configurations that can have real-time index updates for Redis Search. And with that, thank you so much. We'll conclude our presentation.
Thank you, Junaid. So Junaid and Bill, I'll ask you the same question. What's the one thing you would like to have known about Redis now before you'd started the project?
So the best thing actually is the seamlessness of the technology itself. So it's easy to onboard engineers, which we were struggling with. Was like open source Redis. There were some parties that they wanted to work on that, but when we unpacked it a little bit, unpacked the problem a little bit, and we introduced other architectural patterns for high availability, so that made it really apparent for most of our engineers to see that, yes, there's a lot of value in it. And you can search through keys seamlessly across like many clusters. So that was a big learning for us. And it unlocked a lot of opportunities for us that we were able to play around with other modules as well using Redis Search. So, and the whole abstraction makes the development of code pretty seamless and simple to us to do.
Very good. Bill?
It's kind of similar. During this whole implementation, I had to go through several rounds of creating new databases, spawning another one, migrating the data. So I didn't realize it would be so much easier. And also when I have two different, I spin up another one and I have a different set of schemas and everything going in, and things started to break out there, I would get immediate support over that, like seeing why it's breaking out. And it was easier for me to fall back and go forward. So I didn't think it would be as easy as it turned out to be.
Very good, thank you.